So this course is known as Geospatial Cloud Computing. So there are various course learning objectives. These are relevant concepts, methodologies, algorithms, and software packages required for pre-processing and classification of geospatial database. Geospatial capabilities in the cloud, its benefits, challenges, deployment models associated with adoption and implementation of cloud-based GIS systems. Spatial cloud computing, how can the geospatial sciences use and help to shape the cloud computing? ArcGIS server and web editing with GIS server, and learning of geospatial analytics architecture. So this is a 3-unit course, and practical is of 4 units. So and the list of the practical experiments will be based on theory lectures, and the course outcomes include this: it is able to implement algorithms involved in better adoption of cloud-based system, optimize benefits of GIS applications deployed in cloud, capable to make proper selection of cloud GIS offerings as per requirements of the organization, effective implementation of systems for geospatial cloud computing, and finally utilizing cloud computing to address big geospatial data challenges. So what is cloud computing? Cloud computing has been one of the dominant trends regarding accessing computing resources such as processing, storage, and hardware. The convergence of GIS technology with cloud computing has a profound impact on the ability of GIS professionals to leverage spatial applications and information. There are some essential characteristics of cloud computing, which includes network access, on-demand self-service, resource pooling, elasticity, and measured service. So network access means cloud computing services can be accessed from various networking devices such as mobile phones, workstation, and other servers. A GIS example is the Geospatial Information Service that allow access from browsers from other servers. That means when we download any data from Google Earth or any USGS or the Bhuvan website, that is, it stores a bulk amount of data and it connects with the client with the server. Next is on-demand self-service. Cloud computing services should be accessible without having to consult and get permission from a human being. A GIS example is the ability to start multiple map servers by using a browser interface. Resource pooling. Cloud computing resources such as processing power, storage, and input-output are provisioned for different clients from a common set of physical assets. A GIS example is sharing computers owned and administered by S3, Amazon, Microsoft without caring how these computers are being provisioned. Elasticity. Cloud computing services can be scaled up and down to meet demand and decrease the waste. A GIS example is processing a large spatial data set quickly using many cloud computers, which are then discarded when the task is done. And measured service. Cloud computing services are paid or by resources such as processing power, storage capacity, and number of user accounts. And a GIS example is paying for a map server only for a specific time and the bandwidth it uses rather than the whole computer. So there are 3 GIS cloud computing models: GIS public cloud, GIS private cloud, GIS hybrid cloud. And GIS public cloud can be used by anyone. It is freely available for map creation. And GIS private cloud, it is available for specific and authorized users. And the hybrid cloud, it is a mixture of private and public cloud services which are used in conjunction. So this is the logical diagram for the cloud computing, which includes the servers are there, laptop, desktop, tablets, mobile phones, and various applications of monitoring, content, communication, finance, database, object storage, block storage, compute, and network. And these are the application, platform, and infrastructure. This is the logical diagram showing the cloud computing scenario. And the cloud computing service models include infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service is the more fundamental layer on which services are built and platform as a service is offered under the infrastructure as a service, and software as a service are offered under a platform. That is the comparison of how the service models. First, we have to manage the package software, which includes data, software, runtime, operating system, network, storage, and processors. And then infrastructure as a service will be managed by data, software, runtime, and operating system. And the platform as a service will be managed by the data and software, and the software as a service will manage after assembling everything: the data, software, runtime, operating system, network, storage, and the processor. That is managed by the vendor when the ultimate software has to be delivered. This is the overview of the cloud-based GIS model, which includes special storage data, software platform, WebGIS servers, and GIS application. And the service models, which is the platform as a service, which is the ArcGIS server, infrastructure as a service is the Amazon Web Services, and software as a service, which is the ArcGIS Online. So why cloud and GIS are so happy together? Actually, these are useful. Cloud computing solutions are useful in GIS application in various ways, and it also increases the potential power of mobile GIS, since the bulk of computer resources can be stored on the server and can be accessed remotely and very easily. So cloud computing is very useful and advanced technology in several fields, including GIS. Its dynamic scalability and low or zero level investment is beneficial to small and medium scale enterprises. GIS is one of the advanced stream of science, including large set of data processing. So cloud computing is useful for parallel processing of data and important for storing and sharing outputs and results with the end users. Flexibility is one of the characteristics when GIS application is on cloud platform, and it is vital because end user may be located in any part of the world and can be able to access this GIS service using internet and GIS service account. Using this cloud hosting platform can possible to provide analysis service to end user. GIS application hosted on cloud can be available to any end user in the real-time scenario. Availability in real time is a unique feature. So in cloud computing technology, it uses virtualized node and provide instant, numerous, unrestricted access as per user requests. Cloud computing platform provides dynamic configuration. It can provide on-demand access and provides computer nodes immediately as per the request. The cloud computing technique provides large space for storing and functionality of GIS data. It can provide global collaboration platform to GIS end users, researchers, analysts. Cloud virtual machines with public IP address can be accessible from anywhere in the world. Costing depends upon per use and requirement in the cloud computing platform. Virtual machines are hosted on cloud platform, and its hardware continuously upgraded by the service provider, and this machine can possible to migrate on other hosting platform if the hardware fails. This cloud platform is very beneficial rather than the traditional grid and cluster method in GIS applications. GIS application cloud computing platform is a conceptual framework and is vital in meeting high level demands in GIS application and mainly improve usability, scalability, and accessibility of GIS resources. So what is Cloud GIS? Cloud GIS, it is a pure web-based GIS solution powered by cloud computing. It is similar to the web GIS. It provides full desktop GIS features enriched by the web, and with the GIS cloud applications, we can easily and efficiently visualize the data, make analysis, and explore geographic information. And server GIS, ArcGIS server is used for creating and managing GIS web services, applications, and data. ArcGIS server is typically deployed on premises with the organization's service-oriented architecture. ArcGIS server services supply mapping and GIS capabilities via ArcGIS Online for SD web and client applications, ArcLogistics, ArcGIS.com, ArcGIS Explorer, ArcGIS Explorer Online, ArcGIS mapping, and server extension includes 3D spatial analysis tools, geostatistical tools, network analysis, geoportal image, data interoperability, workflow manager, and schematics. And ArcGIS server is available for the Microsoft .NET framework and also in the Java platform. ArcGIS server ships three